Greetings from above NV. This is another video documentary in the What We Do series. Today we'll be talking about 2D and 3D aerial mapping. It's a pretty big subject, so we picked a pretty big job to demonstrate the variety of products and services we can provide. 76 miles north of Elko, Nevada is the Big Springs Mining District. This was actively operated from 1986 until 1993. The mine was closed due to economic and environmental issues. Following the closure, the pits and waste rock dumps were reclaimed to meet the then current environmental regulations. Innova Metals acquired the mining claims over the project in 2013 and have subsequently submitted permit applications to recommence mining. The main purpose of this mapping project is to provide accurate topographic data for final mine design. In a preliminary flyover, we can see that the property is relatively small, but has a great deal of topographical changes and mixed strata. The walls of the pits are really interesting. You can see the ore bodies driving straight through from one side of the mountain to the other. However, as the mine has been closed for many years, climbing around on the cliff faces would be extremely dangerous. There's lots of data available through historic drilling, but up-close view would certainly help the geologist evaluate the property, and slope stability analysis is needed by the mining engineers. We were asked to provide a detailed elevational map for the entire project site. Let's focus on the main pit first, for the purposes of demonstration. Our objective was to get a high-resolution mosaic of the pit wall so that our customer could take a close-up view of the details on the wall. This area is extremely dangerous. We're not allowed to stand anywhere near the pit and obviously stay out of the water. Requiring a very large picture, allowing for zooming in on the individual rocks, we took several hundred pictures and used mosaicing software to put them all together. This is kind of like making one big panoramic picture. The resulting picture is over 250 megabytes. This huge digital picture not only gives us the scope of the wall itself, but allows for zooming in on different areas to see the different layers or the individual rocks themselves. The mosaic uses pictures taken from all different angles and makes a 2D picture wrapped around a particular point in space. Many of the pictures were taken straight down from an altitude of about 100 feet above ground. Using only those pictures creates a high-definition map that's 2D and from the vantage of straight down. This top-down map allows us to make a 2D dimensional map, which is another mosaic but results in a colorized digital elevation map. Combining all these renderings and adding GPS locations provided in each picture, we create a full three-dimensional object view of the pit. This allows for measuring things like the width of the shelf, the amount of gravel on the shelf, and if we wanted to, the volume of the water in the pit itself. Let's get back to the bigger job at hand, and the real reason we came. The entire area needs a digital elevation map. In order to tie the elevation map to a known grid, we need to nail down surveyed points spread out evenly across the entire property. Getting to these points to lay down targets so that the drone can see them is step one. Step two is waiting for the GPS to collect 20 to 30 minutes worth of readings to average out. Later, we'll get correction information from the internet a few days later when we do the post-processing. Once we have the targets out, we can start collecting data. So you're going to see my truck all over the place in these pictures. Next, we flew the site collecting downward-facing pictures from a consistent 400 feet, collecting over 6,000 pictures over the 1.5 square mile area. This is no easy task, given all the topography, wind, and sometimes even snow. We used automation software which takes topography into account and pre-program the drones to do missions with enough overlap between pictures to have each point appear 15 to 20 times. We estimate that the drones flew a total of 100 miles in order to map the 1.5 square mile area. This resulted in a 4 centimeter per pixel resolution. After uploading, we trimmed the pictures down to 4,500 individual pictures, tied them to ground control points, and processed the data over several days. Each picture used is a blue frame here, and each of the blue flags is a surveyed GPS point. After processing, we have what we call a dense point cloud. This consists of 3.8 million tie points and over 290 million ground points. The point cloud has a resolution of 4 centimeters per pixel and an overall accuracy, when we're said and done, of 6 centimeters, which is way beyond the customer's expectations. But those expectations are due to the limited capabilities of old technologies. Drone collected data is just better. Remember when I said we'd see my trucks and some of the raw data? Look at this, 1 truck, here's 2 trucks, there's 3 trucks. So our next job is actually to remove the trucks. We also remove all the vegetation so that we can get a good topo map. Once we do that, we can create a digital elevation map with contour lines at 1 meter. We basically created a super accurate topo map for the entire property. Here's a colorized version that doesn't help the human eye as much as demonstrate the gradient changes our software will be able to recognize when we go back after significant changes to the property. All total, this project took a couple days just to drive there and back, and about 2 days of field work, flying, and about a week of software work. The level of detail is unprecedented in survey technology, and using that old technology to try and even come close would cost about 10 times the price. That said, we had a total blast doing the project, and want to thank Innova Metals for allowing us to use their footage to show people what drone collected data can be used for in a mining and mapping project. We hope this video has been informative to our customers, our students, and the UAV community. Thanks for watching. My name's Kirk, and I'm with Above NV. Give us a call. Let's see how drone collected data can improve your business.